Hello student, we are going to start our today's session. So, digital image processing. Shongita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. Content. Segmentation of digital images. Importance and applications of digital image segmentation. Image segmentation is methods whose inputs and outputs are images, and in which the inputs are images but the outputs are attributes extracted from those images. Segmentation subdivides an image into its constituent regions or objects. The level of detail to which the subdivision is carried depends on the problem being solved. That is, segmentation should stop when the objects or region of interest in an application have been detected. For example, in the automated inspection of electronic assemblies, interest lies in analyzing images of products with the objective and determining the presence or absence of specific anomalies such as missing components or broken connections, paths, etc. There are no point in carrying segmentation past the level of detail required to identify those elements. Segmentation of non-trivial images is one of the most difficult tasks that we are encountered. Segmentation accuracy determines the eventual success or failure of computerized analysis procedures. For this reason, considerable care should be taken to improve the probability of accurate segmentation. In some situations, such as in industrial inspection applications, at least some measure of control over the environment typically is possible. The experienced image processing system designer invariably pays considerable attention to such opportunities. In other applications, such as autonomous target acquisition, the system designer has no control over the operating environment, and the usual approach is to focus on selecting the types of sensor most likely to enhance the objects of interest while diminishing the contribution of irrelevant image details. A good example is the use of infrared imaging by military to detect objects with strong heat signatures such as equipment and troops in motion. Most of the segmentation algorithms we will discuss are based on one of the priorities of intensity values, discontinuities and similarity. In the first category, the approach is to partition an image based on abrupt changes in intensity such as edges. The principal approaches in the secondary category are based on partitioning an image into regions that are similar according to a set of predefined criteria or rules. Thresholding, region growing and region splitting and merging are examples of methods in this category. In this chapter, we will discuss and illustrate a number of these approaches and show that improvements in segmentation performance can be achieved by combining methods from distinct categories, such as techniques in which edge detection is combined with thresholding. We also discuss image segmentation based on morphology. This approach is particularly attractive because it combines several of the positive attributes of the segmentation based on the technique presented. We will discuss this one by one slowly. Now this is the fundamentals. Let R represent the entire spatial region occurring by an image. We may View image segmentation as a process that partition R into n subregions R1, R2 and Rn such that union of Ri is equal to R, where I is equal to 1 to n, means all the regions will be included within R. B. Ri is a connected set, that is to I is equal to 1 to n. C. Ri is in conjunction is not equal to 0 for all i's and j and I not equal to j. These are the predefined and fundamental rules for this segmentation. Now this is an image that is showing. Now this is the first image. Inside it, this is the boundary. Inside it is also means there are two levels of intensities. One is inside is pure white and outside is gray. And if we segment this, then there will be a boundary around this and all will be in equal black. And if we want to extract this, it will be totally white. So this is our segmented portion. In the second, another picture, the same picture with the inside, initially it was evenly distributed, now it is some spikes or salt and pepper types of or irregular texture is inside this. So after segmentation, inside also edges will be connected and inside will be prominent, and this is the outline, and after that it will be segmented and this is the final segmented region. Now, application of digital image segmentation, content-based image retrieval, machine vision, medical imaging, volume rendered image from computer tomography, locate tumor and pathologies, measure tissue volumes, diagnosis, study of anatomical structure, surgery planning, virtual surgery simulation, intrasurgery navigation, object detection, pedestrian detection, face detection, brake light detection, locate objects in satellite images, recognition task, face recognition, fingerprint recognition, iris recognition, traffic control, video surveillance, video object co-segmentation and action localization. Several general purpose algorithm and technique have been developed for image segmentation. To be useful, these techniques must be typically be combined with a domain-specific knowledge in order to effectively solve the domain segmentation problem. These are the references. Thank you. This is all of the day, and in the next day we will continue this segmentation theories and algorithms, and a little bit of MATLAB also we will try. So this is all of the day.